top of 5/8x8 ground rod should be left 1 to 2 inches above ground. This allows for inspection, maintenance, and testing of the grounding electrode system. Leaving the top exposed facilitates visual inspection to ensure the rod is still intact and has not been damaged or corroded over time. It also allows for easy connection of testing equipment to measure the ground resistance. The ground wire connecting two ground rods that are 6 feet apart should be buried at a minimum depth of 18 inches beneath the surface. This requirement is specified by the National Electrical Code, also known as NEC, to protect the wire from physical damage. Burying the wire at this depth prevents it from being easily damaged by gardening tools, lawnmowers, or other equipment that might be used in the area. The NEC provides specific guidelines for grounding and bonding to ensure electrical safety. Grounding is a critical safety measure in electrical systems. It provides a low impedance path for fault current to return to the source, which helps to trip a circuit breaker or fuse and de-energize the circuit in the event of a fault. This protects people from electrical shock and prevents damage to equipment. The grounding electrode system consists of the grounding electrode, which is typically a ground rod, ground plate, or metal underground water pipe, and the grounding electrode conductor, which connects the grounding electrode to the electrical system. The grounding electrode conductor must be sized appropriately based on the size of the service entrance conductors. The purpose of the grounding electrode system is to provide a stable reference point for the electrical system with respect to earth. Bonding is another important safety measure in electrical systems. Bonding involves connecting all metal parts of the electrical system together, such as metal conduit, metal enclosures, and metal equipment frames. This creates a low impedance path for fault current to flow, which helps to trip a circuit breaker or fuse and energize the circuit in the event of a fault. Bonding also helps to equalize the voltage potential between different metal parts of the electrical system, which reduces the risk of electrical shock. The NEC specifies the requirements for bonding in Article 250. It is important to follow these requirements carefully to ensure electrical safety. When installing ground rods, it is important to drive them deep enough into the ground to reach a low resistance connection to earth. The NEC requires that ground rods be driven at least 8 feet into the ground. If rock bottom is encountered before the rod is fully driven, it is permitted to bury the rod horizontally in a trench that is at least 30 inches deep. The resistance of the grounding electrode system should be tested to ensure that it meets the requirements of the NEC. The NEC requires that the resistance to ground does not exceed 25 ohms. If the resistance is higher than 25 ohms, an additional grounding electrode must be installed. The installation of ground rods and grounding wires must comply with the National Electrical Code. This code provides detailed requirements for grounding and bonding to ensure electrical safety. It is important to consult the NEC and follow its requirements carefully when installing ground rods and grounding wires. Proper grounding is essential for protecting people from electrical shock and preventing damage to equipment. Firstly, the ground rods should be installed at least 6 feet apart. This spacing helps to ensure that the ground rods are effective in dissipating fault current. Secondly, the ground wire that connects the ground rods should be sized appropriately based on the size of the service entrance conductors. The NEC provides tables for determining the appropriate size of the grounding electrode conductor. Thirdly, the ground wire should be securely connected to the ground rods using approved connectors. The connectors should be listed for direct burial and should be made of a corrosion-resistant material. Fourthly, the ground wire should be buried at a minimum depth of 18 inches to protect it from physical damage. Fifthly, the resistance of the grounding electrode system should be tested to ensure that it meets the requirements of the NEC. The resistance to ground should not exceed 25 ohms. Sixthly, if the resistance to ground is higher than 25 ohms, an additional grounding electrode should be installed. Seventhly, the ground rods and grounding wires should be inspected regularly to ensure that they are in good condition. Any damaged or corroded components should be replaced immediately. Eighthly, it is important to keep the area around the ground rods clear of obstructions. This will allow for easy access for inspection and maintenance. Ninthly, the location of the ground rod should be documented. This will help to ensure that they can be easily located in the future. Tenthly, it is important to consult with a qualified electrician if you have any questions about grounding or bonding. A qualified electrician can help you to ensure that your electrical system is properly grounded and bonded and that it meets the requirements of the NEC. The NEC specifies that the grounding electrode system shall consist of one or more of the following electrodes: a metal underground water pipe, a metal frame of the building or structure, a concrete encased electrode, a ground ring, or ground rods and pipes. Ground rods and pipes shall not be less than 8 feet in length and shall consist of the following materials: listed materials that are 5/8 inch in diameter, and other approved materials. The grounding electrode conductor shall be sized in accordance with NEC Table 250.66. The size of the grounding electrode conductor is based on the size of the service entrance conductors. The grounding electrode conductor shall be connected to the grounding electrode in an approved manner. The connection shall be made so as to ensure a permanent and effective ground. The grounding electrode system shall be installed in such a manner as to minimize the possibility of damage. The grounding electrode system shall be protected from physical damage. The grounding electrode system shall be accessible for inspection and testing. The grounding electrode system shall be tested to ensure that it meets the requirements of the NEC. The resistance to ground shall not exceed 25 ohms. If the resistance to ground exceeds 25 ohms, an additional grounding electrode shall be installed. The grounding electrode system shall be maintained in good condition. Any damaged or corroded component shall be replaced immediately. Grounding is a critical safety measure in electrical systems. It is important to follow the requirements of the NEC when installing and maintaining grounding systems. Proper grounding helps to protect people from electrical shock and prevent damage to equipment. The National Electrical Code is a comprehensive set of standards for electrical wiring and equipment. It is updated every 3 years and is used by electricians, inspectors, and other electrical professionals to ensure electrical safety. The NEC covers a wide range of topics, including grounding and bonding, wiring methods, overcurrent protection, and equipment installation. It is important to consult the NEC and follow its requirements carefully when working with electrical systems. Proper electrical work ensures the safety of people and property. Ignoring electrical codes can lead to serious hazards. Always prioritize safety and follow best practices. Consult with a qualified electrician for any electrical work that you are not comfortable performing yourself. The NEC is a living document and is constantly being updated to reflect new technologies and best practices. It is important to stay up to date on the latest changes to the NEC to ensure that you are following the most current safety standards. There are many resources available to help you learn more about the NEC. The National Fire Protection Association, also known as NFPA, publishes the NEC and offers a variety of training courses and educational materials. Many electrical trade schools and community colleges also offer courses on the NEC. There are also many online resources available, such as websites, forums, and videos. Staying informed about the NEC is essential for anyone who works with electrical systems. Following the NEC requirements helps ensure the safety of yourself and others. Electrical work should always be performed with caution and respect. Electricity can be dangerous if not handled properly. Always turn off the power before working on any electrical equipment. Use insulated tools and wear appropriate personal protective equipment, such as gloves and safety glasses. If you are not sure how to do something, ask a qualified electrician for help. Never take risks with electricity. Your safety and the safety of others depend on it. The NEC provides specific guidelines for the types of grounding electrodes that are permitted. These include metal underground water pipes, the metal frame of a building or structure, concrete encased electrodes, ground rings, and ground rods or pipes. Each type of electrode has its own installation requirements and limitations. It is important to choose the appropriate type of electrode for the specific application and to follow the NEC requirements carefully. The NEC also specifies the requirements for the grounding electrode conductor, which connects the grounding electrode to the electrical system. The size of the grounding electrode conductor is based on the size of the service entrance conductors. The NEC provides tables for determining the appropriate size of the grounding electrode conductor. The grounding electrode conductor must be made of copper or other corrosion-resistant material and must be protected from physical damage. The NEC also addresses the issue of ground resistance. The NEC requires that the resistance to ground of the grounding electrode system does not exceed 25 ohms. If the resistance is higher than 25 ohms, an additional grounding electrode must be installed. The NEC provides methods for testing the resistance to ground of the grounding electrode system. These methods involve using a ground resistance tester, which is a specialized instrument that measures the resistance between the grounding electrode and earth. Testing the ground resistance is an important part of ensuring the effectiveness of the grounding system. The NEC also covers the topic of bonding. Bonding is the process of connecting all metal parts of an electrical system together to create a low impedance path for fault current. This helps to trip a circuit breaker or fuse quickly in the event of a fault, which protects people from electrical shock and prevents damage to equipment. The NEC specifies the requirements for bonding in Article 250. The NEC requires that all metal parts of an electrical system be bonded together, including metal conduit, metal enclosures, metal equipment frames, and metal water pipes. The bonding conductors must be sized appropriately based on the size of the circuit conductors. The NEC also addresses the issue of equipment grounding. Equipment grounding is the process of connecting the non-current carrying metal parts of electrical equipment to ground. This provides a low impedance path for fault current to flow back to the source, which helps to trip a circuit breaker or fuse quickly in the event of a fault. The NEC specifies the requirements for equipment grounding in Article 250. The NEC requires that all electrical equipment be grounded, unless it is specifically exempted. The grounding conductors must be sized appropriately based on the size of the circuit conductors. The NEC also covers the topic of surge protection. Surge protection is a process of protecting electrical equipment from voltage surges, which are brief but intense spikes of voltage that can damage or destroy sensitive electronic components. Voltage surges can be caused by lightning strikes, power outages, or other disturbances on the electrical grid. The NEC provides requirements for surge protection devices, which are designed to divert voltage surges away from electrical equipment. Surge protection devices should be installed at the service entrance and at individual pieces of equipment that are particularly susceptible to damage from voltage surges. The NEC also addresses the issue of electrical safety in hazardous locations. Hazardous locations are areas where there is a risk of fire or explosion due to the presence of flammable gases, vapors, or dusts. The NEC provides specific requirements for electrical equipment and wiring in hazardous locations. These requirements are designed to prevent electrical equipment from becoming a source of ignition in a hazardous location. The NEC classifies hazardous locations into different classes and divisions based on the type and concentration of flammable substances present. Each class and division has its own specific requirements for electrical equipment and wiring. The NEC is a complex and comprehensive set of standards. It is important to consult the NEC and follow its requirements carefully when working with electrical systems. Proper electrical work ensures the safety of people and property. Ignoring electrical codes can lead to serious hazards. Always prioritize safety and follow best practices. Consult with a qualified electrician for any electrical work that you are not comfortable performing yourself. The NEC is a living document and is constantly being updated to reflect new technologies and best practices. It is important to stay up to date on the latest changes to the NEC to ensure that you are following the most current safety standards.